So I decided to do a blower door test of the existing house just to see how bad it was and to put energy bills in perspective. I've got Michael and Deborah from H&H Small Space Solutions doing the door fan test. I'm going to estimate it somewhere between 8 and 10 air exchanges, but we're going to see how we do. And the purpose of this is to put energy bills in perspective against the door leakage, or sorry, the house leakage, the air leakage. My energy bills per year are under $2,000. And this is going to be a relatively leaky house, and it will never pay in North America's energy costs. It will never pay to do renovations strictly for energy efficiency. The payback is decades often to do a deep energy retrofit. You need to be doing it when you're doing other renovations anyway, and then the incremental cost is a lot less significant. But let's see how we perform. I know
A-ring is everything else.
A vented attic. There's no vapor barrier. There are just layers of paint. There's no air barrier whatsoever. Okay. And there's tons of holes in all the pot lights.
It could be worse. We've tested places that are brand new at 11.
Yeah. But my point is that, okay, this is uninsulated. It has no air barrier to speak of.
Do you really want you see it over the okay? That's not what you're supposed to see it over that thing. Yeah.
That's fine. And I'm less than $2,000 a year for bills.
Yeah.
And we keep it at 72 to 73.
Don't know what that is.
22, 23.
So do you repurpose material from this house?
All of it.
All of it?
All of it. The 2x4s I'm going to use in the new structure. This I'm going to use, it's Japanese sensen. I'm going to try to use that in feature walls or feature ceilings. The flooring I'm going to put in my shop. All the metal will go to salvage. Obviously the drywall will go to salvage. The roofing goes to recycler. The only thing that'll go to the dump is stuff that's like wood that's painted.
You starting at 15 right away?
So 15.
Cool. That loud for 15. Okay.
Wow.
I'm guessing probably 10 air exchanges. What's that mean?
28.
Air exchanges?
Yeah.
Sorry.
Stand here. You can see this.
Yeah.
So I said, wow, because of that much, for... Misha, use the camera, take pictures. Of the dial. Just put the dial down there and just take pictures. Go right up close to it and just take the...
So we're at 24 air exchanges at the moment.
Yep.
At 15 pascals only. Yep. And we have to go up to 50. So one of our largest leaks, one of our largest leaks is underneath a back door, and it's just massive.
No weather stripping at all.
There's probably a 1/4 of an inch gap. It's something that I had stripped up at one point, but because the door doesn't close properly, and around outlets, it's just flying around outlets.
Yep.
And combustion air coming into the house. So lots of different areas.
Service line.
Yeah. The vent going out of the chimney. That's just interior. Another reason for doing airtight ceiling on there's a gap in the weather stripping.
So maybe
We're,
Quite drafty, yeah.
they're, so because that's just
Single
a
pane?
wood on wood, single pane, it's coming, it's bypassing the frames. So definitely a lot coming in around the glass.
Exterior, exterior wall, right? Or is it already moving to the interior wall?
Now if we can get this stuff out of the way and move our way over to the, not bad,
No, not bad at all.
but these windows will be horrendous, I'm sure. Well, you can just see the dust being blown away from the window. Yeah, pretty strong currents. And we're only at minus 15. We have to go up to 50.
Or after 8 you still have open.
Yeah. We're at minus 19, minus 20 pascals, and we're at 23 air exchanges. Funny, the air exchange is actually staying quite stable. It's looking like the air leakage is at low resistance, so it means that it is worse at ambient conditions than it would normally be. Negative 25, and we're at 23.25 air exchanges. So it's, the air exchange is actually going down, which is meaning that as the house depressurizes, it is sealing some of the holes by sucking the two surfaces together. So it's probably sucking the windows tight, sucking some of the doors against the door seals, the gaskets around electrical outlets close to the wall, that kind of thing. We're at minus 29.7, and we're at 22.9 air exchanges. So we're at minus 33, and we're at 22.6 air exchanges. We're at almost minus 35 at 22.85. Doesn't look like we're going to make the minus 50 pascals. It's just too leaky of a house. So what Michael's doing initially is setting the volume of the house and setting a baseline for the door fan test. And we're going to start with what I believe is called an A configuration. Sorry, open configuration, which is with all restrictions wide open, so it can move the maximum amount of air. They're anticipating a fairly leaky house that will push the fan to its limits. So a confession here: we had already gone through a series of pressures, and I accidentally deleted the video. I'll post those onto the blog once I get them from Michael and Deborah. So I know already that the house is performing quite poorly, so now we're just going to do a full throttle just to see how poorly it's performing. So we're at minus 25 pascals, and we have 22.45 air leakages per hour. Now, I'll also say that on the previous testing, what we found is that as the depressurization of the house increased, the air leakage actually decreased because we were tightening up interfaces. As we put suction on the house, windows would pull shut, doors would pull to the weather stripping, gaskets on outlets would pull to the drywall. Everything just got a little bit tighter, and as a result, the air leakage went down. But that's actually the worst case scenario, the worst that you want to see, because it means that ambient temperatures, your air leakage is much higher because it doesn't have that suction. Right now we're at minus 29.5, and we're still just over 22. We just dropped below 22, 21.85 at minus 30. And we're at 21.9 air changes per hour. At 35. So again, as we depressurize, we're sucking the surfaces together and tightening up the house. So maybe at 50, we'll tighten it up down to maybe a 5 air changes per hour. Wouldn't that be nice? But that'll show a misleading concept with the testing at 50 pascals. If you can have a house much tighter, then it's going to perform in actual environmental live conditions.
Well, therefore, you should actually test the multi-point.
Yes.
Test in 5 increments between 15 and 50 pascals.
Yeah. What would be like a normal day with some minor winds? How many pascals would that be? 7? 10?
No.
Less?
Probably 2.
2? Yeah. So we're at minus 40 pascals, and we're at 21.4 air changes per hour. And is that on full throttle yet?
No.
So we still are going to try to get up to 50 pascals. We're at minus 45, and we're at 21.35. It'd be nice if we at least broke 20. But this just shows how bad old houses can be. I certainly haven't been diligent about air sealing. I've done quite a bit. I've sealed all of the cedar siding. All of the laps of the cedar siding have been sealed with silicone. The siding's been sealed to most of the windows. But what we're seeing is a lot of leakage into the attic through all the electrical outlets, and a lot of leakage at the wood frame windows around the. So we made minus 50, and we're at 21.05 air changes. So now we'll just do a quick smoke test. Put it down there. It's right there. Foot of my boots. Yeah. So we're just going to do a smoke test. It shows the air current, so you can see that window is just blowing the air, the smoke out of the way. Around those casements, single pane aluminum frame windows, there's just no sealing whatsoever around them. And we've got sealing. That one's it's not bad compared to the window, but there's still a lot of flow. Light switches. Oh, big time. Just blowing out like crazy. How about around the fireplace here? Yeah, that's blowing pretty good too. That's in direct communication with the attic. Let's look at a modern window. and compare. This was replaced a few years back, and it should be, it is relatively tight.
Check the plumbing.
That's not too bad.
That's not bad at all.
Yep.
It hangs around for a while.
Plumbing?
Plumbing underneath the sink.
Yeah.
So you can't really see it, but it's just blowing that like crazy out of there. And that would make sense because the bathrooms were always quite cold. The bathroom and the kitchen. Check this window. So this window, I've always had cords going through it for the, and you can see it's like a gale force wind coming through there. And then of course our back door has never, actually you can just feel the air coming in here. That's just blowing through. Never really done too much on this door because we had a cat door in it, so it's always had a big hole, and it's just flying through here. It feels like you're on the front of a ferry walking into this room. It's quite remarkable. Every time you walk through a door into a room, you can feel the amount of air flowing from that room into the rest of the house towards the door fan. So huge plumes being blown around here. You can smell outside. Somebody's burning a fire. I smell cedar or something like that. So this door was really, it's just, you can see that on the camera hopefully, it's just like hurricane winds blowing it through. And these windows, they're wood frame, and funny enough, they've actually sealed up a little bit since the lower pressure test. The air is hanging around. They used to be blowing pretty strongly, and now the air hangs around a lot more. There's some good convection currents happening. But they were actually worse at lower pressures. Exterior outlets. Yeah, you can see it just instantly dissipates, pushes it out. Ceiling, we're sucking a lot of air from the attic area. So there you have it. We're minus 50 pascals, and we have 21.75 air changes per hour official.